presentation. So as you may be able to see, just to minimize any interruptions and disturbances, you could kindly just switch off your notifications and you'll see the instructions on the screen, and you may be able to turn them back on after the presentation has concluded. So today, for our virtual open week for this year, we'll be having our lecturers' insights in industrial automation engineering here at EIT, and it will be presented to you by the insightful Dr. A.K. Rahman, which is our course coordinator and on-campus lecturer in Australia. And then we'll also be hearing from our student ambassador, Diana Swartz, and they'll be basically taking you through the whole presentation. May I kindly just inform you that the PDF and link for this presentation will be sent to you between Monday the 14th and Tuesday the 15th this month. So just keep an eye out on your inbox. Even if it's not there, alternatively, just check your junk mail or spam folders. Alternatively, it could be in the promo folders. And then with the certificate of attendance, you will be able to receive a free certificate of attendance. There will be a link and QR code, and that will lead you to a survey that you can complete, and you will receive your certificate of attendance between Monday and Tuesday the 15th. And in addition to that, you will be entered into our competition. So without further ado, Dr. A.K. Rahman will be starting the presentation. Dr. A.K., you may take the control and begin the presentation.
Thank you so much. Can I just quickly confirm that you guys can hear me? Kumo?
Yes, sir. I can hear you.
Wonderful. Thank you so much. Hello again, everyone. I can see quite a lot of people have have joined the session, so thank you so much. And hello to all the members of the arranging team as well. So I'm very happy to have gotten the opportunity to present this presentation today on the insights in industrial automation. So I'm looking at the agenda at the moment. So I'll just give you a quick briefing of what we are covering in this session at the beginning from my point of view. So we'll have a quick introduction to me as well as EIT. We'll also be discussing about EIT's industrial automation. So a bit of background history on what is industrial automation, how that relates to potential job outcomes, which is obviously a very big reason of why we're delivering the course, and how that relates to future, job opportunities, and also that will relate to what courses that is currently running at EIT on industrial automation and how that's relevant to the industry needs. I'll also provide some of the unique features of EIT, what it offers, and how it relates to the trending topics in industrial automation, as I mentioned, and some of the examples of industry standard industrial IA tools like software or hardware at EIT that for conclusion and questions at the end. All right, so a quick introduction of myself, as you can see. So my name is Dr. Akhlaqur Rahman. Everyone calls me AK. So I've been with EIT for almost 6 years now. I'm the lecturer and course coordinator for the industrial automation courses. So all courses related to industrial automation by higher ed, I look after those. I have almost 13 years of experience in teaching, developing, coordinating, supervising all courses in related to industrial automation, industrial IoT, communication, Industry 4.0, anything related to automation. I have expertise in that area. My original background is actually in Bachelor of Science in Electrical and Electronics Engineering from Bangladesh. So I did my bachelor there, and I did my PhD here from Swinburne University in Australia, Melbourne, Australia, where I'm currently residing. So as I mentioned, I've been with EIT for almost 6 years, developing and upgrading quite a lot of courses related to IA as well as developing as well. And also, besides that, as EIT extracurricular activities and leadership opportunities. I have also worked as ex-secretary for IEEE Victoria as well as IEEE Communication Society Victoria, and actually IEEE Young Engineers Society for Victoria as well. All right, let's go on to the actual presentation topic that we have today, and that is about industrial automation engineering. So I can see we have almost 55 people who are joining this session today. So may I just ask a little bit of feedback from some of you to be participating in the session? Can you just maybe give me a quick idea of what do you think of what is the first thing that comes to your mind when I tell the word automation, right? Just write in the chat here, if possible, if any, those of you who can, write this. What is the first thing that comes to your mind when you think of the term automation? Okay, you can see Manu here is talking about processing. That's good. Process engineering is a big part where automation is taking over. Different processes requires automation now to, meet the requirements of current industry. Is there anyone else? Just mention the first thing that comes to your mind when you hear the term automation or industrial automation, anything. It can be anything that, or something recent in your recent time that you'll be hearing a lot about that's related to automation. I can see Kumar is mentioning streamlining. Very interesting. Yes. So automation definitely relates to streamlining as well. So ultimately, any process that you're talking about, yeah, automating, it's actually streamlining that process ultimately to get to the results in an automated manner. I can see Safisa has mentioned AI. Yes. Shireen has mentioned robotics. Jeff has mentioned robotics. I can see Charles has mentioned control and data acquisition. All valid and all related to automation. To be honest, if you think about robotics, programs, yes, Jeff, control. Douglas mentions about PLCs, controlling PLCs, DCS, SCADA system, robotic programming. Christopher mentioned the use of technologies to control systems. Yes, all of these are actually automation. And I think also Safiso was mentioning about AI. So I think in recent times, there hasn't been probably any topic that has been discussed more than AI. So what is AI ultimately? You are using assistance to help you with your calculation or your communication or developing some work. That's actually part of automation as well. Jonathan mentions digital. Yes. So when you talk about digitalization of a particular industry, that's also part of automation. So thank you so much, everyone, for your feedback. So that's actually very good. Now, if you just quickly reflect on the responses you have given, quite a lot of you can see they're all different, slightly different. Processing, control, AI, programming, PLC SCADA, industrial processes, streamlining. So it's quite broad, digitalization. And that's what industrial automation is. And that's what is unique about industrial automation. So if I have to present what is unique about industrial automation, it's actually not just one thing. People from different industries can come to an industrial automation, take it up as a course, learn something, and have an impact on their industry. That's what is unique about industrial automation. In fact, I will show you now how it is really presentation as well as you see. So the question obviously is, what is industrial automation? So industrial automation is the use of control systems such as computers or robots or IT technologies for handling different processes and machineries in an industry to assist a human and take over their responsibilities. So automation is okay. I think, yeah, thank you, Kumo. I think I have pressed, yeah, okay. I can see that I have taken over the screen. Okay, all good. Yes, so thank you so much. So as you can see, as I mentioned, industrial automation is the use of control systems like computers and robots to make processes simpler, where you're streamlining the process and you are asking to assist the human being to and eventually taking over their job. So automation ultimately, whenever they hear this thing, uh, taking over the job, people do take it sometimes in a worrying manner that, okay, if AI is taking over my job, where does that leave me? And I'll tell you about that in a minute. But the first thing that I should tell you when you're talking about industrial automation is not to worry. So, this is a part of the human evolution and industrial revolution as well. So, ultimately, the whole purpose of industrial automation is as technology is progressing, you're finding help from technology to make your work, different processes simpler and streamlined. So that's what automation is all about. Around you, your computer, your internet, your public transport, your private transport, your communication mode, your television is has everything is related to some sense of automation and industrial revolution. So that's why automation is very broad in its nature, and people from different industries are all related. So, what I want to do at this moment is try to explain to you why industrial automation is so relevant, right? Because I think all of you who are probably attending this session have heard about electrical engineering, civil engineering, mechanical engineering, even process engineering, chemical engineering, there are electronics engineering, even robotics. Automation as its own stream is something unique that EIT provides. And as I mentioned, people from all these different backgrounds that I just mentioned can come to automation and also learn their craft and provide it back into their industry. So that's where automation is so broad. Now, why is automation important? So, in order to understand that, we have to answer the question, automation. So, if you look at it, one of the terminologies that again is very popular with automation nowadays, and I'm writing it in the chat, is Industry 4.0. So some of you may have heard this term. So again, if I write actually what is the first thing that comes to your mind when I say Industry 4.0, some of you may answer some of the same answers like digitalization, like AI, like IoT. So a lot of those things. So we are currently in the middle of the fourth industrial revolution or industry 4.0. So when we talk about automation or industrial automation, we are talking about the current age of industrial automation, which is industry 4.0, as I've written in the chat. Now, the first thing that should come to your mind as a question is, so if this is industry 4.0, that means there should have been an industry 1.0, 2.0, 3.0. So what are they about? So this is what I just wanted to do a quick briefing about. So we are in the middle of Industry 4.0. So what is it and what is the history of industrial automation? So as you will see, ultimately what has happened is over the last 200-300 years is with new technology, people have found a way of using it in the industry and making it their own revolution. So if you look at it, the first industrial revolution actually happened about 250 years ago, late 1800s, where they found the power of mechanization. So, what is mechanization? To use the power of hydro or water. Basically, they found a way that water force can be used to industry for some industrial purposes. In this case, the idea was to simplify the agriculture and transportation operations. So instead of manually grinding a lot of these grains and doing a lot of the process, you could use the power of hydro to run the machine and run those steam engines or use them for agricultural purposes. Based on that, a whole industry was created. So more people could actually do that as a job, and that could fasten up the process. So that was the first industrial automation or industrial revolution, or first time people doing something or automating the process to an extent. Then came Industry 2.0 about, I would say, 130 years back. So the question would be, what happened 130 years back? We had the invention of electricity. So when electricity was invented about late 1800s, 1890s, so obviously compared to around 120 years later of Industry 1.0, they yeah, started running what we call assembly line. So think of it like in a factory. Nowadays, what you're doing, making the same products in a batch, right? So instead, if you think of it as a simple example of, let's say, five people are standing in front of a conveyor belt, and you're making a sandwich. So someone is putting the bread, someone is putting the mayonnaise, someone is putting the ketchup, someone is putting the salami, someone is putting another bread. So now you're making a sandwich, a delicious sandwich, right? Now, imagine instead of that, now you're building a car and you're doing different parts by yourself. So instead of building one at a time, you are now working in a batch. And that's what came with the idea of electricity. And that was the second industrial revolution. And with new technology, new ideas came in, and automation progressed. Then came Industry 3.0 about 50 plus years back. What happened then? Again, computer and IT networks. So when computer was invented, people started eventually developing machines to solve complex problems. So you could, in this diagram, as you can see, manually control this machine with the programming to run it. So you can run a particular operation where you are manually controlling these operations. Instead of doing this work by hand, you are now controlling the machine at the plant floor and doing it using the machine, using your programming skills. So that was the third industrial revolution. Quite a lot has changed if you think from Industry 1.0 to 2.0 and now 3.0, slowly moving away from the action. And that's what happened after about a decade back, about 10, 15 years back, when Industry 4.0 arrived. So Industry 4.0 is what we're currently in the middle of. So it's actually aided by the invention of Internet of Things. So what is Internet of Things? Now, instead of controlling this one machine, these multiple machines can now among themselves. So now these machines are smart enough to use their own internet, hence the name Internet of Things, can communicate with each other and make some decisions on their level. So for example, at a plant floor, if you want to check the temperature and if it's not below a certain level, the sensors may adjust accordingly to keep the temperature at a particular level. If you have a robot that is supposed to do particular action when the temperature goes high, based on that, they might do some different actions to control the temperature. So now, instead of you going manually and changing the operation, you are actually monitoring it from the far away or maybe at an upper level and also making changes remotely or not even remotely, but not directly. That's the idea. So this is what automation has done. So if you look from the first industrial revolution to now, every point, the role of human has changed. So people who were doing the previous work, their work became maybe to an extent replaced by the machine, but that actually created more opportunities for the humans to learn new skills so that same industry just in a different space. And that's where we are currently at. So in the middle of Industry 4.0, where you have all these new technologies, smart cars, smart robots, smart watches, smart mobiles, smart house, everything is smart. That makes humans need to skill up to apply those changes in the machines in a smart way. And that's where you guys are currently. That's where you are trying to upskill yourself so that you can integrate with this new stage of industry. One thing that's not part of it here, but I'll just quickly mention, is Industry 4.0 we're currently in the middle of. What happens after Industry 4.0? it will come Industry 5.0. So that's another exciting part. I won't have much time to present it here, but that's where robots and humans will work side by side. With AI now, you can see how more work is becoming powerful, AI supporting. If AI can support robots as well, we may be able to work side by side. Again, your skill set will need to upgrade at that point as well. Anyway, so ultimately, what we're trying to say is 75 million jobs may be displaced by a shift in the division of labor between humans and machines, but 133 million new roles will emerge. So there is always more roles emerging than the roles that are getting lost. And that's because you, all of you attending this session, probably have a goal of upskilling yourself so that you can And that's what industrial automation is. It's a journey where you're constantly upgrading yourself. So hopefully I managed to give a good idea of the background of industrial automation. It's nothing new. That's all I'm just trying to say. It's been there for 100, 200 years, 300 years, and you are just doing exactly what people before us have done, and people after us will probably do as well. It's very natural. So, with that in mind, and keeping the idea that I've already presented that industrial automation is a broad area, right? So, industrial automation is a broad area. That means people from different backgrounds can come to this area, and people from this area can go to their different industries as well. So, when you look at a potential job areas for industrial automation, robotics and mechatronics engineers. So that makes quite a lot of sense because in industrial operations, you're working with lots of robotics, robots or machines. And for that, you'll need to learn automation. So automation is all related to control. Control of what? Control of machines, control of robots. Potential job. Industrial engineering. Industrial engineering, I think of it as a management role. So obviously, if it's an industrial manufacturing process, there is obviously management role there as well. So you need to have the knowledge there. Control engineering, obviously, control is one of the key things. So there are three key aspects that I feel is very critical for automation to be learned. So I'm just writing it in the chat as well for everyone. Control, instrumentation, and programming. So control engineering makes sense. Electrical engineering. Electrical engineering is probably the closest that's aligned with automation because control is also part of electrical and electronics as well. So that's why people from electrical engineering, especially in power engineering, you'll see there is a lot of people invested in automation there. Power system, cybersecurity, power system, smart grids, obviously microgrids, virtual power plants, power engineering, everything is related. There is the role of automation there. Process engineering, someone already talked about process. I remember, I think it was Marno. Yes, Marno mentioned about processing. So process engineer, chemical process, chemical plants. That's one of the main areas for which automation was also developed as well. So process engineering, automation makes it a very important contribution. Um, Uh, Thank you, Christian. That's good to know. So it's good to, that you have a better idea of what the background of automation is. So it's quite related to everything around us, actually. That's what's very interesting about automation. Also, you can see industrial communication. So, for example, a simple one would be, let's say you're connected to the computer. Your computer is now connected to um, HDMI cable, and that's connected to an extra monitor, right? So your laptop and you're connected to a monitor. Have you ever thought why this cable that is connecting the monitor with your laptop, it just perfectly fits? Well, way that it kind of fits because your monitor could be from a different company, but your laptop could be from a different company, but the cable just perfectly fits like a USB or a C cable or an HDMI. It just perfectly fits. Why? That's part of industrial communication. That makes automation very important. If you can convey the message to the machine, you can do ask it to do more tasks. So that's part of automation. Oil and gas instrumentation. Again, in oil and gas industry, in remote engineering as well, automation is playing more and more part, especially safety with technologies such as drone technologies, or again, communication plays a very important part in uncertain scenarios. So that's another one. IT OT security convergence. So there was a as an industrial automation engineer, is it possible to work remotely? Yes. Yes, you're absolutely correct. You can, especially in oil and gas instrumentation, you can probably work remotely as well. So yeah, so going back to the point, I'll probably answer the questions at the end. Sorry about that. So IT OT security convergence. So obviously you have the IT part, which is like the programming side, networking side, and you have the OT infrastructure, which is the hardware. So a lot of jobs, especially from industry experts I have heard, is this bridge OT is somewhere people actually a lot of job has created in the last few years because people have IT expertise and people have OT expertise, but someone who can actually pass on the problems from the OT to the IT people, that part is actually still very vague. And as a result, people are probably a lot of the industrial processes are getting hampered. So that area also has a lots of potential jobs as well. So again, with the need of every operation becoming open, right? Everything is now open in Industry 4.0. That means a lot of data is passing through. So data security is now more important than ever. But what is this data coming from? It's from the hardware as well. So someone who can actually pass on this information between the or bridge the gap between IT and OT will also have a job as well. Um, so how does this apply to architecture and design? That is actually a very interesting question. I'm an architect by profession. Well, I mean, if you look at design, even if you look at civil engineering, right, or building design or something like that, you have obviously heard of 3D printing, right? So 3D printing again is a very critical part of automation nowadays because with 3D printing, what's happening is your industrial operations is becoming more faster and more flexible than ever before. If previously you would make, if you wanted to make a slight change to an existing industrial process or design process, it would require you to stop the whole thing and start from the beginning. But as you're moving from Industry 4.0 to 5.0 eventually, the whole idea is there will be more customization and there will be finer details that you can change throughout the process as well. So there is a thing called digital twin. So what happens is, let's say you have an industrial manufacturing process, they would make a virtual version of that parallelly. And if you want to make any architectural or design changes, you would make it there in the virtual version and see in real time what that change might impact your scenario. And then it will then, based on the outcome, you may change it in the hardware. So that's one way it can impact it. The other one is digital twin. You can check based on the design itself if there is any fault or if there is any maintenance required based on the results that you're getting with data analytics, and then you can change it in the industry as well. Anyway, so that's one way. I'll probably move on a bit. So far as you can see, so no worries. So that just gives you an idea of how broad the potential job areas for AI, automation is. Now, what EIT is offering. I'm very proud to say that EIT is one of the first universities that actually has always promoted industrial automation and as its own stream. So you can see we have courses in advanced diploma, so advanced diploma of industrial automation and engineering. We have bachelor courses, that's 3 years, bachelor of industrial automation engineering. We have master's courses, master of engineering in industrial automation, as well as we have graduates and undergraduate certificates, which are subsets of the bachelor and master's courses. So it's actually, you may do the graduate certificate, and then if you want to continue to the master's course, you may. So, and obviously you have different professional certificate for industry people who already are working and maybe, let's say, just need to learn about PLC, but or they have some idea about PLC and SCADA, but doesn't have much knowledge about instrumentation and control, or they have knowledge about PLC but not much knowledge about SCADA. So for these things, EIT is actually offering lots of professional certificates as well. The good thing about industrial automation is it's actually how well it aligns with the significant trends that is currently of in practice. Already mentioned. So I think Griffin has mentioned, how does this apply to drafting and designing and doing mechanical drafting and designing? Again, I think it's very hard to, yeah, so drafting and designing particularly is in my area, but ultimately everything related to designing, you can now actually do using simulation as well. And with technologies such as 3D printing and digital twin, the whole process can actually now have virtualization. So you can create a virtual imprint of what you are doing and use that to parallelly mock your actual hardware. But what it does is it helps you make changes in the virtual version much simply or easily than you would in the practical world without having consequences. So that's probably one way of answering that your question given. So I can give you the exact one with the mechanical drafting because that's not my area, but yeah, with designing, I can answer that. Okay. Yeah, so with the talking about the significant trends, as I was saying, IoT, as I mentioned, everything is connected nowadays. AI, someone already mentioned it. AI is the centerpiece of automation. AI is everywhere, so is automation. Machine learning. So AI actually works with machine learning as well. So a lot of data that is currently being used, you can use that data to provide different output. So that's where machine learning comes in. So all of these terminology that is mentioned here will be covered as part of the courses here at EIT. So machine learning, smartphones, renewable energy for power engineering, virtual and augmented reality, collaborative robots, that's part of Industry 5.0, how robots can actually work with humans in a safe manner, as well as cyber security as well. So there was a time when automation was only about instrumentation, right? But nowadays it's become so broad. There is software engineering involved. Cyber security, that's also part of automation. There are automated way of actually theft detection or virtual data blocks or whatever you want to call it. So there is different aspects from cybersecurity to renewable to data analytics, IoT, everywhere there is imprint of automation. And you can see again some of those trending topics that I already talked about, how that aligns with what EIT offers. So digital control, someone talked about digitalization, right? So digital control, it's covered in some of our units here. You can see industrial process control, industrial instrumentation, advanced process control. So part of the master's course. Machine learning, we actually added our own courses on machine learning and data and masters, and we got amazing feedback from our students. So we're so happy that this was added and they actually used it in their industry once they learned from here. So that was uh, very helpful. There is also cyber physical system and IoT. So as I mentioned, we have advanced diploma in robotics. We have certificates in PLC, SCADA. We have, I personally developed this course, the professional certificate in industrial IoT, which is a subset of IoT, but for industrial operation that can relate to Industry 4.0. So that's one of the most up-to-date courses we have. And you can also see And that's what I mentioned. So let's say a professional certificate of competency in big data and analytics in electricity grid. Suppose you're from the electrical background, you have some knowledge, but you don't have knowledge about data analytics. So you want a customized course for you that actually impacts big data and its impact on electricity or power engineering. So there is a professional certificate here that can be of benefit. So that's how I mentioned automation can help different people in their different industries. Again, with robotics, as you can see, we have advanced diploma. We have courses in bachelor in robotics and mechatronics. We're working on developing more courses, in fact, and even with cyber security, as I mentioned, IT, OT, cyber security. There is modern industrial control systems and protocols. So it's about communication units. This is my area of teaching actually, but yeah. So there are lots of courses, and so ultimately, what we are trying to say is automation is a course that is built on the fact that there is a need in the current context. That's why we have kept the course as well, like that as well. So whether it's bachelor, master's, advanced diploma, so professional certificates, it's up to date about the current needs. And you can see that in some of our lab content as well. So some of our tools, by that I mean is some of our lab experiment tools. So for example, you can see the PLC kit that we use, right? So I'll answer that question in a second, Joseph. So as you can see about PLC kit, so that's part of our graduate certificate course. So you'll be able to do programming as well as hardware and remote experimentations on PLCs. You'll see for SCADA, we use a software called Plan SCADA, which is an industry standard software. Through our remote labs, you can actually access those industry software for free. As a result, if you are already working in an industry, that's fine. Or if you apply for a job and they ask you, have you ever worked with this industry standard software? You can say, yes, I have. I've done projects on them. I've developed a SCADA system as part of my degree. So that is a benefit of what we are offering. You can see there is a building a neural network. So again, related to machine learning, we have our own units in machine learning, and it's very popular, as I mentioned. In fact, I think the most thesis projects we have seen in the last few years for masters is on machine learning because of the addition of these courses. Also designing a process controller using MATLAB. We have a campus-wide license for MATLAB, so it's very popular there. The remote labs I created personally. So it's this remote lab is using IoT. So IoT being very popular nowadays, you can use the concept of IoT to remotely control these switches and these lights from your own home. So using the remote lab. So that's a remote lab or remotely controlled lab. And that mimics an industrial manufacturing line setup. So that's how just you can just see how IoT is working. Similarly, you can also see application of your study. For example, this is talking about forecasting electricity demand. So you are using machine learning, you can actually do forecasting as well, and using certain algorithms, and you can implement that in your thesis as well. So that just gives you a broad idea of different industries where you can actually have contribute, or rather you can contribute because of your knowledge in industrial automation. Okay, so I think that's all from my side. Oh, okay. Uh, I don't know what I need to do because I don't get I'm not seeing the sync to presenter sign sufficio here.
No, not you, Dr. AK.
Okay,
The
yeah.
participant will need to sync their presentation to yours. The slides are moving. We are on slide 21 at the moment.
Okay, okay, all good then. So I think that's all from my side mostly. I think there's one other question I did see. I'll just probably quickly answer that. So, as an electrical engineer, is cybersecurity important? Joseph, yes. So, cybersecurity will become an integrated part of all engineering in the next 10 years, because all operation is moving towards open connected operations where data will be coming from different sources and moving to different sources. So as a result, cybersecurity will become a big part in all industry. If you're electrical engineering, so the first part where it will be is power system cybersecurity. There is a whole area of power system cybersecurity where in fact, even in Australia, some of our power systems are really have poor cybersecurity and are vulnerable for attack. So, as cybersecurity engineer, if you have knowledge in electrical engineering, you will have a very good opportunity for jobs because that area is still untapped, but will have a lot of demand in the next few years. Also, CM is asking what sort of skills an automation engineer should master. So, as I mentioned, programming, control, instrumentation, and another thing I'll probably add nowadays is data analytics as well. So this will become very useful. Data analytics and will not be a novelty in a few years. It will need to be a knowledge, just like, learning computer and internet was a big deal 20 years ago, but nowadays it's normal. Similarly, data analytics will become like that as well. All right, I think I've done all from my side. So, Kumo, I think I'll probably just give it back to you.
Thank you, Dr. AK. That was very interesting. So next we will have our student ambassador, Dinah. I don't know if she's managed to fix her situation with her connectivity. Oh, there we go.
I have. Thanks, Kumar.
Thank you. You may take control of the slides and you can start. Thank you.
Thank you. Sorry, I can't see the slides anymore. Um,
Yes, yes, you can't see the slides anymore. Let me just try and re-upload them. 2 seconds. Okay, they're coming up. Okay, well,
awesome. Success.
okay, there we go.
Okay, that's great. Awesome. Thanks, guys. Thanks for having me. My name is Gamuchirai Diana Swartz, and I am a 2025 Student Ambassador. So I am an automation engineer, currently working as a project engineer slash project manager in New Zealand. As of, I guess, last year, more or less. So I migrated after having spent quite a bit of time in South Africa. I started with a bachelor's in electrical and electronic engineering, and I transitioned to automation. So when Dr. AK mentioned that most people come from an electrical and electronic background, it sort of fit into, well, into my career progression. So I found out about EIT from an engineer that I worked with who was mentoring me. We were actually in in an automation mining environment, and it seemed like every other person that I spoke to had gone through EIT. So actually going in and looking at the connections that I have on LinkedIn, I found that quite a few people have completed some professional certificates, others have gone for the masters, but a bulk of the people that I'm actually connected to have gone through EIT. So I was inspired to choose this program because as is the case with most people in automation, you don't really start out with an automation qualification. You're starting off in a different environment and working your way into automation. So having built my knowledge from experience, the logical next step was to actually study it. And as I went through the different modules that EIT had to offer, I actually found that they were directly applicable to the kind of work that I was doing, and it was knowledge that was easily applied per project, per instant, to a point where sometimes I'd actually come across situations and get into a course that addressed the questions that I have that people around me couldn't answer. In terms of a memorable moment or a challenge, the thesis project was quite a bulky piece of work that required you to do your research, to talk to people who have the necessary knowledge. Again, going back to the points that Dr. AK raised, I am one of the multitudes of thesis students or master students who focused on machine learning and how it can be used to optimize operational efficiencies in our plants. So looking at your traditional methods of control, it was quite interesting to see just how much further AI and machine learning can push your plant and can optimize your production with well a high initial investment, but eventually like the payoff is quite great. So looking at advice that I would give to students studying with EIT, I mean, at the end of the day, the biggest investment that you can make is an investment in yourself. And at the pace that engineering moves at, we really don't have the time to lay back and be complacent. So I think if you're interested in studying, then look at the courses, look at where you can start and just jump into it. Because I remember looking at the as a course and thinking it's going to take 2 years and that's a significant investment of time. But looking back, it's either you sit back and you go through the 2 years and you've got nothing to show for it, or you've got the 2 years and you come out with a degree. Essentially, you've got nothing to lose. So, in terms of how it's broadened my perspective, academically and personally, it's been a lot of academics and a lot of professional development. I find that a number of the courses that I came across, for example, professional engineering management, I work in an engineering management space right now, and I found that the references to professional management are actually very similar to what the Project Management Institute has in terms of their project management body of knowledge. So things that I learned at EIT are things that I'm now applying in my job and also applying towards getting my PMP certification. So it's not something that appears as brand new. It's something that adds on to the knowledge that I already have that I've attained as a result of studying with EIT. Another example is machine learning for industrial automation. That was mind-blowing, seeing the different applications in industry and also just pairing that with advanced process control, which is more like a different subsection, right? It's process control, but it's process control that can be enhanced by machine learning. So I find that these days when I look at projects, when I look at different applications, I have more knowledge than I had when I started. And I definitely see how it has improved my understanding of the industry and also improved my offering. So, and then just to wrap up, I guess from my side, my favorite aspect of studying was the flexibility, being able to move, like I would be commissioning in the DRC, I would be on a flight, back to Johannesburg. I would be in the waiting room. And even then, I'd be able to actually get my courses done, to get my coursework done. I remember even the day that I moved to New Zealand, I had an engineering management assessment that I needed to submit. And I finalized that when I was on the plane. And eventually, when I landed and I settled in, that's when I submitted. And I understand that I wouldn't have been able to do that in a traditional learning institution. So they have been many benefits for me personally studying with EIT. And even after completing the studies in December, I still find cases where I can go back to my modules, refer back, have valuable information and knowledge that I can add to the team. So grateful for the opportunity. Thanks, guys.
Thank you so much. That was really wonderful to hear. And now, if anyone has got any questions, we may answer your questions for the next few minutes. Ndubusisi, you may ask your question. You can type it in the chat box or in the Q&A box.
Kuma, I think you're muted.
Oh, thanks. Dr. AK, okay, yeah, Dr. AK has answered Joseph, and then Joseph would like to apply for an online course. Yes, Joseph, you can go on our website and check which course may be of interest to you, and you can apply from our website. And then Ahmed Ali is asking, what PLC brand should I learn? Should I learn TwinCat, Allen Bradley, or Simmons? Thank you, Dr. AK. And then another question.
Yes, I think I can answer that probably better. So, Ahmed, it depends on what you actually are in particular wanting to learn. We have some professional certificates on SCADA as well, so and DCS. So, if you want to just specifically learn about that, you can definitely contact some of our course advisors, and they'll be able to guide you exactly the professional certificate that will cover that. So, and also give you the knowledge of the, as I mentioned, the industry standard software that is used to implement these. So that will be, I think, helpful there. So that will be the first step.
Okay, we still have some time for a few more questions. If anyone's got, you may go ahead and just type them into the Q&A box or into our chat box here. Okay, so Ahmed said, is the industry moving towards into open source software such as codices or ignition? Is SCADA systems are moving into front-end web deck? Dr. AK, I think
So
that's one for you.
yes, yes. So it's very. So I think okay. So the best way I can answer that is yes. So the industry is definitely embracing more open source, and the terminology they use is vendor independent platforms. So things like codices or even they are definitely now widely more adopted and supports more hardware brands as well, and supports more open technology. So, and also it's the reason for that, obviously, I think you know because you've already answered the question, but lower cost, and obviously more scalability, flexibility. So that's the reason. So that's definitely the right answer, as you mentioned. Uh, Sorry, I forgot the second part. I can't see it. Just give me a second. So, sorry, it's okay. SCADA systems are moving into front-end web deck as well. So again, it's a yes question. So again, the idea being that things like Ignition or Factory Talk, even Aviva, what the name I think something related to Viva. They're good examples basically of SCADA solutions that has more web-based front ends actually. So they're definitely modern SCADA systems are more transitioning to web-based, what's the word, UIs. I think, yeah. So yes, to both of you in that question. So you already know, which is good. Okay, I
Thank you.
can see there's a couple of questions. Yeah.
Okay, can I take Christopher's question about which course, if he would be eligible given his qualification and experience? So, Christopher, you can just reach out to one of our course advisors and they'll take you through the entry requirements for each of the courses, and then maybe you can just have a discussion to see which one will best meet your interest. Okay. Okay, guys, so I've provided in the chat the links for the certificate of attendance, and then you can also just take a look at the virtual open week webinars that we'll be having. And then if you would like to book a call with one of our course advisors, please use our Calendly link, and that will help you just set up a call, and they'll give you a call just to basically go through whatever it is you may want to inquire about. And the registration for our webinars is there, and the link to our courses that are upcoming are also, I've provided that as well. So if there's nothing else, we can go ahead and wrap this up. Thank you all for attending, and hope to see you in our next webinars. Thank you so much, Dr. AK, and thank you, Diana, for giving us your experience and everything that will help our potential students and all the students that have already been with us. Thank you so much. Have a good day, all.
Thank you, Kumar. Thank you, Diana. Thank you, everyone.
Thank you. Thank you for
Bye.
having me. Bye.